Welcome to the CSIS 113B Lecture 2 on data types. In this lecture, we'll be covering literal values, so we're reiterating what we covered back in the first lecture. And then we'll be focusing on variables, how to declare them, initialize them, and assign values to them. We'll also talk about variable naming rules as well as naming conventions. We'll take a look at value types. That's very important to strongly typed languages like Java. You always have to define the type of value that you're going to be storing in the variable. That way the CPU knows how much memory to reserve for that particular variable to store the value. And then we'll take a look at getting input, how we can receive input from the keyboard using the scanner class. So that's a class provided with the Java library. And we'll talk a little bit about escape characters, which is a way of using special characters to generate special attributes within your string code. And we'll also be talking about operators, which is how we manipulate our variable values. In computer programming, one of the things that you'll most commonly be dealing with are values. And values are discrete quantities of data. We have some examples of some literal values here. So a literal value just means the actual value itself. And you'll hear that term used a lot in computer programming. We talk about the literal, we're talking about the actual value, not any representation of the value. In the examples that we see there, there's a whole number, there's a couple of numbers with decimal places, then we have a character, and then we have several characters or a word. And so all of these different values, whether they be whole numbers or numbers with decimal places in them, single characters or words, they all need to be stored in a computer's memory at some point, and that is done so by using zeros and ones. In fact, you may be familiar with that. That's referred to as the binary numbering system. Binary is the only thing that computers can process and store, either in memory or on some sort of a storage device. Now, values which are numbers, because they're already numeric format, they're quite easily converted to binary. But values which are symbols, like the character H or @ symbol, or even the characters that make up the word hello, they must also be represented by binary values. So this process of converting letters into numeric values is referred to as character encoding. And how we determine what the numeric values are then to represent all these different characters and symbols can be found in what's known as the ASCII chart. So ASCII goes all the way back to the days when we only had 7 bits or 128 characters, or then later on 8-bit ASCII, which gave us the ability to have 256 characters. But these days we use another character encoding scheme referred to as Unicode. And Unicode is 16-bit, which means that we can now represent over 65,000 characters. If we go to the website ASCII-code.com, you'll be able to see what we're talking about here. We'll skip down past these initial 32 characters, which really are just form feeds and carriage returns, ringing the bell on an old terminal computing device. So nothing we need to worry about with regards to symbols and characters. So starting with the character decimal value 32, that represents a space. Then you can see decimal 33 is an exclamation point. So now we're getting into some of the symbols that we find on keyboards. Further down now you can see we get into the numbers. Now the letters, and notice the letters are organized by capital and then by lowercase. So for instance, if we look at the capital letter A here, you can see it's the value of 65, whereas the lowercase a is a value of 97, or H That's a value of 104, and that's the lowercase h, whereas up here we would have the uppercase h, which is a value of 72. And those are all decimal representations then of the characters, and you'll see that we also have a column here that has what the binary representation of the characters are. So this column here would represent the way that these characters or symbols are actually being stored in computer memory or in some sort of a storage device. The decimal values are generally for human usage, so when we're manipulating the characters within our programs and whatnot, we'll deal with the decimal values of the characters. Getting back then to the slide, the next to last bullet point there talks about the value of hello. So notice that hello in the second bullet point here is different in the way that it's being encapsulated. It has double quotes around it, whereas the letter H, which is a character, an individual character, has single quotes around it. So in computer programming, we treat those differently. We have a char data type. We'll get to data types here in just a second. But an individual character is considered to be of a different data type than is a collection of characters, which is referred to as a string literal. And the last bullet point there then asks you if you want to go back to that ASCII-code.com webpage, see if you can determine each of the individual decimal values for the word hello. So the capital H, the lowercase e, the lowercase l's, and the lowercase o. So now we take a look at the values and their data types. So values represent different kinds of data. In a computer program, this is known as then the data's type. A data's type determines how many bits are required to store that data value in memory, what types of operations can be performed on the data, and what the default value of that data type is. So if we declare a variable that's going to hold a certain data type, but we don't assign a value to it, there will be a default value assigned to it. As you can see in the table there, in the far left-hand column, we have our literal values. So true or false, negative 128 to 128 positive. The number 1, which is a whole number, as is the negative 128 and positive 128. And then below the number 1 there, we have decimal values. And then below the decimal values, again, an individual character. And then underneath of that, a entire word, which is a collection of chars, a collection of characters, which is known as a string. So for each of those rows then, you can see in the second column we identify the data type. So true or false represents a Boolean type. The range of numbers, whole numbers, between negative 128 to positive 128 can be referred to as a byte type, although they would also be of integer or int type. And so the other thing to realize here is in that data type column, what I'm giving you is the way that Java will represent that data type. So when we go to declare variables, you'll need to indicate the type of variable that you want to create, and those are the type names. So an integer, that's its real type, but in the Java programming language, we shorten that to just int and refer to it as an int. So an int type is just an integer, but int is the way we must declare the actual variable that's going to store that integer. And then a float means that we're going to have decimal places in the number, as does a double. You'll notice the difference between those two, if you move over to the third column, is just the size. So a float is maximum 32 bits, so you can't have quite as many numbers within a float range, whereas with a double, it's 64 bits, so you can have quite a few more numbers. And then our char, so that's short for character, but again, that's the actual type that we use when we're declaring a char or a character variable. We use char, C-H-A-R, which is of size 16 bits, because remember we're now using Unicode character encoding, and so that's a 16-bit format. And then finally we have what's called a string, which is a collection of characters. And again, I want to remind you that chars, you'll always indicate single characters in single quotes, whereas when you have multiple characters, you'll use double quotes to surround those letters, those characters. And then there is no limit to the size that we can have, other than the system's memory, perhaps, the size of word that we can store in a variable. When we move over to the third column there, that's the default value for each of the types. So if we declare a variable of type Boolean, but we don't actually assign a value to it, the default will be false. Byte types will have a default value of 0. Integer types will have a default value of 0, as will float and double, but you actually put an F and a D after the numeric value so that we can signify which is the float value and which is the double value. And then individual characters are of type Unicode, so that's what the \U represents there, and then 4 digits to represent the 16 bits of possibility, but that's the lowest we could have in a Unicode set, right? Would be all zeros. And then a string, if we don't assign a value to a variable that's being declared as a string, then it'll have a null value assigned to it. Then finally, in that far right-hand column, we have sort of this superset grouping of our data types. You have either value data types or reference value types. So you'll see that all but the string are value types. And we won't get into too much depth here, but it just determines where the values are being stored in the computer's memory, either on the stack or on the heap. So all your value types, those actual literal values are being stored on the stack. Whereas a string, which is technically not a primitive type, it's more like a class or an object, those are reference types. And so the memory location, they get stored on the heap, and the actual literal value is being stored on the heap. But on the stack, the address to the starting location in memory where we'll find that value is being placed on the stack. So reference types, the memory address is being placed on the stack, and that memory address points to where the literal value is being stored in the heap memory, because they're much larger than the stack can store many times, and so we have to move them into the heap. And so the only way to be able to reference them so that the program can find them when we need it to is to put the memory address of where it's being stored in the heap. Okay, so now we start getting into variables. So the way that a program defines, creates, and modifies variables are using these types of statements. Declaration statements, where, and in the Java language, which is a strictly typed language, you have to identify both the type and a name for your variable when you declare it. So the example we have there is int type, and then X is representing the name of the variable. And it's a statement, so it's going to end with a semicolon. So the variable that we're declaring is X, and it's of type int. So at that point in time, 32 bits of memory are allocated on the stack for the variable X. So anytime that we refer to X within our program, the computer will be able to go and find that location in the stack memory and grab the literal value to use in our program. Now, variables wouldn't be very useful unless we assigned literal values to them, and so we have also assignment statements. So an assignment statement is where you actually then assign a literal value to a variable. Now in the example there, we're showing you x equals 1. So first of all, you have to be aware of the fact that x had to have already been declared here at this point, because we're not identifying the data type in this statement. We're only identifying that we want variable x to be assigned, and that's the single equals symbol that you see there. That's the assignment operator. So you've got x is being assigned the value of 1. So it is possible, when we take a look at the third statement, you can see this, the initialization statements. Let's first point out that initialization statements are the initial value of a variable. So whether you do it during declaration or during a later assignment, as soon as a variable is assigned a value, it is being initialized. So that could be that you do it during declaration. You can have both declaration and assignment occurring at the same time. So that's the example you see there with int x being assigned the value of 1. So now we're declaring the data type, we're assigning a name to the variable, and we're assigning a literal value to that variable. So that's the declaration plus an assignment, referred to as an initialization statement, because we are initializing the value of that variable. And then in the second example, or the last example on this screen, so now we've got our previously declared variable x being assigned the value 1, and it's the first time that a value has been assigned to it, so that is also a initialization statement for that particular variable in that particular situation. Continuing on with variable declaration. So the declaration statement specifies a name that represents an address location in memory. Value types on the stack and reference types go on the heap. We talked about that. The kind of thing or type that's stored at the location. So we've got the name and we've got the data type. And remember, the data type always goes first, followed by the name. So again, we have an example here. This time we're creating a variable of type int, and it'll be named age. And since it is of int type, 32 bits of memory are being reserved, and then because it's an integer, it's being reserved in the next available location on the stack. And then to the right, we have a graphic example there to kind of show you exactly what's going on here. So age is actually being linked to a memory address in the stack. And we haven't assigned a value to age yet, so you can see the gray box to the right doesn't have any value stored in it. So declaration, all we're doing is assigning a name that gets linked to a memory address. And in this case, because it's an integer, that's the beginning of a 32-bit section that's being reserved in the stack. And the last set of bullet points there, we're talking about making sure that you use the variable appropriately. You know, one of the reasons that we type our variables is so that we don't make the mistake of, say, putting a string value into an integer variable. That would not work. So if you tried to do age equals hello, in other words, assign the word hello to the variable age, that is not going to work. The other thing that's important to note here is that you must declare a variable before you can assign a value to it. So you can't just willy-nilly in your middle of your program say age equals 32. If you haven't previously declared age as a type, an int type or a float or a double type, whatever the numeric type is you want to assign to it, if that has not been declared previously, you cannot assign a value to it. So declaring a variable is analogous to writing a name and a type on the outside of a box, which then stores things of a particular size. So variables are allocated and deallocated a storage location, either the stack or the heap memory, while the program is running. So most modern day programming languages will take care of the deallocation for you. It's called garbage collection. So if we reserve space in memory, once we're done using a particular variable, if the program detects that, it will actually free up that space for us. The required memory amount for a variable can be anywhere from 1 to any number of bytes in size, depending on its type. And before initializing, in other words, assigning a variable, reference types will have a null value. We saw that in the table that we were looking at previously. And your primitive types, the value types, will have default values, again, as we saw in the table, 0 or false. If you remember, the numbers were all 0 and then the Boolean was false. The variable's memory location will hold the value of the variable once it is assigned. So we declare it, we're putting a name and a type on the box, and then when you assign a value to it, that value gets stored inside of the box, essentially. Again, that's an analogy, right? It just represents space in memory. So in the 3 examples of the 3 boxes we have, the name here now is going to be I for a type integer, and that's going to begin at address location 5000. So that is a 4-byte box, right? It's an integer, 32 bits. So that's 4 bytes, 4 times 8, 32. So then moving on to the next box, if that's the next item to be stored in memory, then we're creating a CH of type char. So the name is CH, the type is char, and its address begins at 5004 because it has to be 4 blocks down the road from 5000. We don't want to overwrite the end of our 4-byte box, right? We got to begin after the end of our 4-byte box. So it begins at 5004, and because it's a char, then it's going to be 16 bits or 2 bytes. And then our last box there will be 2 bytes down the road from our char, and that one's going to be named R. It's going to be of type double, so that's a 64-bit box or 8 bytes. 8 times 8, 64. So what we're essentially getting at here then is that we're stacking these boxes up in memory. So this is a representation of the stack that's being used for our program here. So again, we've got our 3 variables with the names I, CH, and R of type int, char, double, and the beginning address locations. And then the graphic to the right there just kind of shows you that beginning at 5000 in memory, at address location 5000 in memory, is the reference to our I variable. And then further down, reference location 5004, so it just takes up the beginning 1 byte in memory, so it's CH or char variable. And then 5006, the beginning double is created. It starts at 5005 and goes up to 5012 because it's 8 bytes in length. Returning back to our terminology again, initialization statements assign a value for the first time to a variable. So it's a special kind of assignment. You can also consider it to be an assignment statement. So it's the first assignment of a value to a variable, and it's referred to as initializing the variable, and it can be done in conjunction with a declaration. You must initialize a variable before you can use it. This example uses new age is equal to age, so we're assigning whatever is stored in the age variable now to another variable which is named new age. However, new age has not been declared yet, so that's an illegal statement. Since new age has not been declared, since there's not already a location in memory reserved for storing a value for new age, attempting to assign a value to it will throw an error. So that's an illegal statement. Now in the next bullet point, we have age equals 23. Now that's legal as long as age had already been declared. If it hadn't been, and we wanted to assign a value to it, as we talked about previously, we could declare it and assign the value at the same time in a single statement. And so int age equals 23 would be correct. In fact, that's missing a semicolon there. Otherwise, without the semicolon, that's an illegal statement. And then assignment is just simply assigning a value to a variable or replacing an existing value in the variable. So again, in this example, we have to assume age has already been declared, age equals 25 semicolon. That would be a legal statement, again, as long as age had already been declared. There are some rules when it comes to naming your variables. So your variable names can consist of letters, numbers, the underscore character, even the dollar sign. And even though the dollar sign is used, really we recommend that you don't use it. Variable names cannot begin with a number. So although numbers can be within the name itself, it has to begin with a letter, an underscore, or a dollar sign, which again we don't recommend. Also, when you're creating a variable name, you can't use an existing Java keyword. I mean, that makes sense. You'd have a conflict with regards to the compiler. It wouldn't know whether you were referring to the variable or you're referring to the keyword. So keywords like if, else, new, for, anything that's in the keyword list. And if you do a search for Java keywords, you can get a list of all of those. Also, variable names cannot contain a space. So the first example there, int, is the data type, and then the name that's being attempted is my space var. So that's illegal. So the general rule is we use what's called camel case when we're creating variable names or method names, and Pascal case when we're creating class names. So what camel case means is that when we have a multi-word name, the first character is lowercase, and then each subsequent word we capitalize it. So this is a two-word variable, essentially, my var. So since the first word is my, we're going to start that with a lowercase m. Second word is var. We're going to go ahead and capitalize the v in var. That's camel case. So as I said, class definitions, they'll have Pascal case. So that means that the first character of every word in a multi-word name will be capitalized. So you can see the example there, my Java class. Each word there is, the first letter is capitalized. Methods use the first word character lowercase, so it's camel cased as well. The example here, my Java method, so my lowercase, Java and method both have a capital first letter. And then variables use that same naming convention, camel case. So get used to using those conventions. That way it helps you to recognize the different components of the program when you're going back and reviewing them. Now, referring back to the different data types, we can organize those data types into categories. So number types, meaning any type that represents a number. So we've talked about integers, which are whole numbers. And then there's a question posed to you there about the letter A. So technically, A is a number. Remember, that's how it's actually stored in memory, as a numeric Unicode value. And actually, the value can be converted to a decimal that represents that Unicode value. Remember, everything's in binary when we're talking about a computer and storage. Anything to do with storage, memory, which would be, memory, drives, all that kind of stuff. Zeros and ones, that's all the CPU understands. And then the other number type is our floating point types, which are real numbers, which have decimal places. Here we have a list of the different Java number types. So we have the Boolean, which is 1 bit, 0 or 1, and only two possibilities there, false or true. The default value is false. A byte is 8 bits or 1 byte long. It could be a value from -128 to +127, and its default value is 0. A char, 2 bytes, and so that can represent 16 bits, which is what Unicode, the Unicode character encoding chart is 65,535 characters. So if you do the math on 2 to the 16th power, that's what you're going to get, 65,536 actually. But we're starting from 0 there as opposed to 1. So it has a default value of U \, which represents that it's a Unicode value, and then 4 zeros. Short, remember, is just a smaller integer, so it's 2 bytes, 16 bits long, so we can represent the numbers from -32 up to +32. Integer is 4 bytes, so 32 bits, so we can go to -2 billion up to +2 billion. And then a long is just a larger int. It's 8 bytes long, so 64 bits. And you can see we've got very large numbers we can deal with there. Float is our real numbers, those that have decimal places in them. So we've got the 4 byte float, and then you have the larger float, which is the double, and 8 bytes or 64 bits. in all the numeric values, they all default to 0. Boolean is a 0 as well, false being the way it's represented in human terms. Here we're talking about losing precision. This is dealing with our number types. If you take a double and try to convert it to an int, ints don't support decimal places. And so that's where we're going to lose our precision, obviously, because in some languages they would actually convert that just to 33 and get rid of the numbers to the right of the decimal place. In Java, though, attempting to store a double into an int actually does throw an error. It'll pop up as a loss of precision error. And as I said, in other languages, the example here, C++, if you take a double and you try to stick it into an int, it actually just truncates the int, the double, to the integer value. Now you can store smaller data types into larger ones, so if we take an int and then store it into a double, that's not going to be any problem. Now there are times when you might need to convert a double into an int, and so we use a method called casting, and we'll demonstrate that a little bit later on. Here we're making a comparison of the primitives versus the complex types. So everything we've looked at so far has all been what we call the primitive values. They're all values that can be stored on the stack because they're not a longer width than what the actual CPU can process from the stack. So our ints, our chars, floats, doubles, boolean, those are all considered primitives. Value types, they get stored on the stack. Complex types are classes which are stored on the heap because generally they're going to be larger than the width of the stack. The stack is always whatever type of system we're using, currently 64-bit systems, that's the widest value that we can store on the stack. So the heap, because it's dynamically created, it's random access memory, we have the ability to store much larger values in the heap than we do on the stack. And so that's where we have the complex types being stored. So when this comes into issue is when we start using classes. What we'll show you in a little later example that we're going to take input from the keyboard, and so we'll need to use the Java scanner class to do that. And so we'll create an instance of the scanner class. So that means when we create an instance of a class, we need to store that in memory so that we can use it in our program, and so that is going to be stored on the heap. So anytime that we create an instance, you can see the example here is on the left. We're first defining the data type. So the data type is going to be scanner. Then we define the name that we're going to use in our program to refer to that class, myScanner. And then we've got the assignment operator followed by the new keyword. So that's where we're actually now creating the instance of. We're copying from the actual class scanner and assigning it to our variable myScanner. And again, it needs to be stored in memory. So the new operator is being used to create the instance of the object. So a class is the actual file. When you create an instance of that, a copy of it, they refer to it as an object. And then in this particular case, we're passing a parameter into the scanner as we create it as a new instance, and that's the system.in, and that's what allows us then to actually use an input stream reader object, which is just another class, but that gives us the ability then to take input from the keyboard. Objects then have the following. They have an identity, so that's the name that we assign to the object instance, so myScanner in this example. And then as part of the code base that we're copying over from the class that becomes our object, there's also properties or fields in there, and that's referred to as the state of the object. And then behaviors are the methods that come with the object, the actual actions that we can perform on the object. So a little deeper look at objects. Again, we talked about identity. In our example, myScanner is the identity of the object that we're creating. So as we copy this class code using the new operator, we're assigning that into myScanner, which now is referred to as an object within our program. And then again, system.in is the parameter. And actually, when we're calling it, when we're generating a new instance of it, it's referred to as an argument. So when you're passing a variable to a new instance of something, that's referred to as an argument. When you yourself actually create the class and identify what it will allow to be passed into it, you refer to them as parameters. So that terminology can, I know, get a little bit confusing. So the caller refers to the argument, calls it an argument that we're passing into this new instance. Again, if you were to write the actual code that is the class scanner, and you would have defined what parameters that your scanner class would accept, you would refer to it at that point in time as parameters. So just make a note to yourself on that, because those terms may confuse you as we go through the rest of the class. State, again, is just properties, fields, values that we store with regards to the object. They're also referred to as attributes or characteristics of the object. So just think of them as variables that are defined within the object itself. We call those the global variables. And we define those, by the way, within the class, but outside of any method in that class. And that's what makes them global. And then behavior, as I said, is just basically the methods that we build into the class. They usually allow us to modify the variables or the fields that we've placed into that class, or any values that have been passed into the object as parameters. And then the graphic on the right there, just kind of breaking everything down for you. MyScanner being the name of the receiving object. Then we have the dot operator, followed by one of the methods that make up that class, which is now part of our new object, MyScanner. It's called perform task. And then the argument, again, is the value that's being passed into the object. The reason we talked so much about classes and objects in the last slide is to make sure that you'll understand this slide and why really that we're using a complex type now to type our new variables. And that complex type is the string type. It is a class in Java. It is not a primitive. So remember, the primitives are always all lowercase. When we go to define a new variable that we want to contain a string inside of it, we'll need to use capital S string as the data type. So as you see in the first example there, we're creating a variable named hello string. Notice that's camel case because that's a variable name, but the data type is string, the class name. So string is the type, hello string is the variable name, and then we're using the assignment operator to assign the text hello to the variable hello string. Now we can concatenate strings using the concatenate operator, which is the plus symbol. When we're using strings, the plus symbol is the concatenate operator. So again, we're creating a new string type. The name of this variable is myString, also camel-cased. And we're assigning to it the contents of our first string, hello string, and then concatenating to that space world. So myString now contains hello space world. Another way of doing that, adding the space and then the world, is in the next example that you see there. Again, we're just creating the same variable, myString, and again assigning the original contents, hello string. This time, though, we're concatenating the space separately and then concatenating to it the word world. Either way is fine. Just realize that either is necessary. When we're concatenating two words together, if we want to make sure we have a space in there, we have to take that into account. Now, because string is a complex type, it has properties and methods. So one of the methods that we have for a string is the length method. That'll calculate how many characters there are in the string. So the example we're using here now is we're creating a primitive variable, an int type, naming it length, and then assigning to it the length method of our string. So our string is hello string. We want to calculate how many characters are in that string, so we use dot notation here. So the name of the variable, hello string, dot, and then the method, which is going to calculate the number of characters. So the actual value is 5 that is being returned back to that length variable, being assigned, I should say, to that length variable, because hello has 5 characters in it. And in the last example, just creating one more variable, this again of type int, a primitive type, new length, so it's camel cased is the name. It's being assigned the length now of my string. Remember, my string is hello plus the space plus world, which is 11 characters long. So new length, the variable name new length, contains the number 11. Here are some more string methods. We can determine where a particular character exists within the string using the char at method. You just saw length. We can also take a section, a portion of the string, and assign it to a variable using a substring, identifying the first location or the first character within the string where we want to start, and then how many characters we want to have it count to get all the characters between the start and the end. If you just put substring and then a single integer value in the parentheses, it'll start at that character number and then go all the way to the end of the string. Index of, that will find a particular character. You just put in the character you're looking for in the parentheses. So that's the parameter, the argument I should say, that we're passing to the index of method. And that'll identify numerically where that particular character is located within the string. You can also replace characters within the string, identifying the starting location and the ending location. And you can convert a string to all uppercase characters, and you can convert a string to all lowercase characters. Now we're looking at how to take input from the keyboard. As I mentioned earlier, we use the scanner class to get input from the keyboard. And that's not available to us by default when we create a new Java program. So we need to import it into our program. That means we add an import statement into the program just after the package name but before our class name. We want to have an import statement, and for the scanner it's going to be java.util.scanner. So the import statement just simply makes the scanner class available to us. In our code, when we want to actually use the scanner, as we talked about earlier, we need to create a new instance of the scanner. So the example that we're using in the second bullet point here is we're going to create a variable named in, which will be of type scanner. And then we'll assign to it a new scanner object, and we pass in system.in as the argument, which gives us access to the keyboard input. And then the slide just makes a point there that when we're passing in system in to the scanner object, that the constructor method of scanner is where that's received in the scanner class code while we're creating the new instance. And we won't get real in depth there, but basically the constructor methods allow us to retrieve, to have arguments that we send into new objects and get different variations of a particular object depending what we pass into it. So once the instance of scanner has been created, in this case we assigned it to our variable in, then we can go ahead and use it. And so in our last bullet point there, you can see that we're creating a new variable called value. It's of int type, and what we're assigning to it is the value that came in from the keyboard as an integer. So we use our instance name in, and then the method that comes with the scanner class called nextInt. So we have nextInt and nextDouble. In this case, we're expecting the user to type in an integer, so we use nextInt. So the int named value now holds the next whole number that was typed in from the keyboard. And here you can see the scanner methods. So for each of the different data types, it's just next in whatever the type is. Next byte, next double, next float, next int, next long, next short. Or in the case of string input, it's next line. Now that we've talked about input, let's talk a little bit about output, which is creating output to the console. In this case, we use the system class. As you saw earlier, we can use a print or print line. And again, print line is going to move the cursor down. Print is not. And as we're outputting our text to the console, there are what are called escape characters that we can use to modify how that text is being output. So if we actually want to have text being output on several lines, we can actually break the string up and put in a backward slash n in there. Notice it's a backward slash, not a forward slash. And so anytime that you add that character combination, so backslash is the escape code, and then whatever the letter is after it, that designates what that's supposed to do. So N is for new line, backslash R is a carriage return, backslash T lets you add tabbing in your strings, backslash F is a form feed character, and then backslash B would be a backspace character. So here's an example of using the new line escape character. In this case, we're using, again, system.out.println. The text string, though, you'll notice has hello, and then between hello and world, backslash n, so that means it'll be hello, new line, and then world typed on the next line. We saw concatenation earlier using the plus sign with strings. Now we're looking at arithmetic operators, meaning we're going to be using the operators that work with numbers. So these are the basic ones that you learned in elementary school. If you want to add values together, use the plus symbol. If you want to subtract, it's the minus symbol. In order to multiply, we don't use the x, since that would be a char value, so we use an asterisk to represent multiplication. And then division, we use a forward slash character. And then the modulus, which means remainder, is the percent symbol. So when you take a look at that example, you'll see that we're taking the number 5 and dividing it by the number 3. And the result there is not 1 and some decimal places, because we're using integer values which have no decimal places. So what the modulus operator does is says, well, what's the remainder of that operation? So if we divide 3 into 5, which would give us 1 initially, we still have 2 left over, right? So that's what the modulus gives us, is what the leftover value. Integer division then can be a little bit tricky because we don't have decimal places. Here we give you an example where we set up an integer x 7 and an integer y 3, which I should point out, because we really haven't shown you that yet, how we can actually initialize two variables of the same type if we just simply separate them by commas. So we put in the int type x equals 7, comma, y equals 3. So that initializes 7 to the value 7 to x and the value 3 to y, both as integers, all in the same statement. Then we initialize the integer z with the results of our division, x divided by y, so that would be the number 2. And in a division problem, we would have decimal places after that. That all is going to be truncated at that point. We're only going to get whole numbers as a result in an integer value. So to get the remainder, we use the modulus operator. So then we give you that example. Integer remainder is equal to x modulus y. That's going to hold the value of 1. So now we have z holding the results of x divided by y, which is 2. And we have the remainder variable holding the results of x modulus y, which is the value of 1. Earlier we had mentioned typecasting. This is an example. We talked about how when we create doubles that you can't put a double inside of an integer. So if we tried to do the operation x equals z, so z being a double, a real number having decimal places, and we try to assign that to the integer x, we're going to get an error. So if we have to do this, we can do it by using casting. And that's what you see in the very last line there. Before we assign the z to x, we cast z to become an integer. So if you just put in the data type in a set of parentheses before your variable name, that's called typecasting, meaning take the normal type of Z, cast it, change it to an int type. That will work. Now it is going to truncate everything past the decimal point, so the result is going to be 33, but that conversion won't create an error for us. Here we're looking at unary operators, which just means that the operator operates on only a single operand. That's the plus plus, which is the increment operator, and the minus minus, which is the decrement operator. Now it depends on whether you add the plus plus before your variable name or after your variable name as to how the results occur. So we have what is called post increment, meaning we're adding the increment operator after the variable name, or pre-increment, where we're putting the increment operator before the variable name. So let's take a look at that. First of all, we look at both the increment and decrement operator in the first box there. So we've initialized an integer x with a value of 0. And then we use the post increment operator, so x now is the number 1, so we've incremented it by 1. And then in the second example there, because it follows our previous calculation where we incremented x to 1 with the x followed by the decrement operator, now it goes back to 0. So initially x is 0, we increment it to 1, then we decrement it back to 0. In the second box, we're using the post increment operator, which is just what we saw really up above there. However, it is being added to a calculation where we're multiplying. So let's take a look at that. We initialize x as 2, we initialize y as 0. Then we assign y the value or the results of calculating the number 1 times x where it is post-incremented. That means it's actually incremented after the multiplication operation occurs. So what that means is x is not incremented, it's still 2 when it's multiplied times the number 1. Compare that to the last box where we're using the pre-increment operator. Now we're putting the plus plus before the x. So now when we calculate the value for y, it's 1 times, and then we do increment x, which currently is at 2, so we increment it by 1. Now it's a value of 3. We multiply that times 1, assign it to y, and y then has the value of 3. So that's a really important concept for you to get a grasp of, the difference between post-increment and pre-increment. Another way to increment or decrement values for that matter is by accumulation. So you can see in the example here we are initializing an integer called counter with a value of 0, and then to increment it we just simply use the variable name on the right hand side of the assignment operator with a plus 1 after it. So it's a mathematical calculation. Counter, which is 0, plus 1 is 1, and then assign that to counter on the left. So that makes the counter variable have the value of 1. So this is called accumulation. We can use this when we want to have a counter in our program, keep a running total. And you'll see this again when we get to iteration, which is where we loop through code and repeat it over and over again. There is a shortcut operator for this to streamline accumulation. So you see in the last example there, we have initialized counter again as an int with a value of 0. But this time we don't duplicate the variable name counter. We use the plus equals operator to actually add the value to the initial variable. So it's counter plus equals 1. So plus being what the value on the right is 1 to the original value of 0. And counter now has the value of 1. So there is a shortcut operator to streamline this accumulation. We can do plus equals or minus equals or multiplies equals. You can use all of the mathematical operators with the equal sign in this way. So in the last example, you can see again initialize the integer counter with a value of 0, but this time to increment it by 1, it's counter plus equals 1. And here's a list of the shortcut operators. As you can see, all the mathematical operators, as we showed you earlier, can be used for this process. So plus equals, minus equals, times equals, divide equals, modulus equals. And you can even put formulas to the right of the assignment operator using any one of those combinations of symbols of those shortcut operators. So here's a code example for you. You can see that we have imported the scanner class so that we can take input from the keyboard. And now we've started a new class called console. Inside of our main method, we have declared a variable val, V-A-L. Then underneath our comment there, you can see that we're creating a new instance of the scanner class and assigning it to a variable named in. Then we create a prompt for the user to read, which reads, enter an integer and I will square it. So then the user will enter an integer from the keyboard, which we will then use the instance of in the next int method to get that integer value that they're typing in and assign it to our val integer variable. And then we'll square it by using the shortcut operator times equals, so val equal times equals val. And then we just output the results with the print line statement. The square of your number is, and then we concatenate to that string the contents of val. Now val is an integer, but just know that when we use print line, it'll automatically convert that integer value to a string as it is concatenated to the existing string on the left there. So let's review now what we've learned in this lecture. We talked about literal values. Those are the actual values that we assign into our variables. And then we talked about declaring, initializing, and assigning values to our variables. And remember, it's important that we declare our variables before we assign values to them. And initializing a variable means that we can both declare and assign in a single statement. We also looked at the variable naming rules and conventions. Essentially, you want to name all your variables starting with a character. And as far as the convention is concerned, we want to use camel case whenever we're naming variables or naming methods. Classes use the Pascal case where we capitalize everything. We introduced you to the categories of our value types, numbers, objects, and strings. So objects and strings, basically a string is a class or an object itself, whereas the numbers are primitive types. We looked at getting input, so using the scanner class so we can take input from the keyboard. We also introduced you to the escape characters so that we can add line feeds and tabs and things of that nature into our output to the screen. And we talked about several types of operators, the mathematical operators, and then also the increment and decrement operators and the shortcut operators for adding, multiplying, etc. So that is the end of Lecture 2. Until the next time, happy coding.